This is Algebra 1B Part 2, Unit 2, Lesson 3, Graphing Square Root Functions. You may recall that to graph a squared function, the equation y equals x squared, we use the squared numbers. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 5, or 3 squared is 9, all right, and so forth, right? And when you square negatives, you get a positive, so you end up with this shape here, this shape. You get this parabola shape, 0, 0, 1, 1, 2, 4, 3, 9. And on the left side, we get the same thing. Okay, square roots are very similar to this, with one important distinction. You only get half the parabola out of a square root. Square roots are the inverse or the backwards form of squaring. So the square root of 0 is 0. The square root of, and let me change colors here, the square root of 0 is 0. The square root of 1 is 1. Now for going backwards, the square root of 4 is 2, because 2 times 2 is 4. The square root of 9 is 3, because 3 times 3 is 9. So if I were to graph in the same coordinates these points, 0, 0, starts at the same place, 1, 1, so far is this the same, 4, 2, 2, 4 to the right, and 2 up. That's where it differs. 9, 3. Okay, and let me move this off to the right here a little bit and make a little room. Okay, so 9, 3, 2, 4, 5. Okay, right here. Okay, so we go right there and try it again. There we go. Okay, and you'll notice it is the kind of the shape of a parabola, but it's lying on its side, and it's only half of the parabola. Okay. In fact, if I were to erase this half of the original parabola, they would be the same shape, just flipped over the line, over the diagonal line. Okay. If you can imagine them flipped over a diagonal line. In fact, let me show you in Desmos. It's really kind of cool. All right. So Desmos. Not des least, but des most. If I graph y equals x squared, we get the parabola. If I graph y equals square root, and for square root sqrt, square root x, I get that funny looking half parabola shape. Now if I restrict the domain on the y equals x squared by saying x has to be greater than or equal to 0, I get a perfect match. In fact, look at this. If I graph the line y equals x, the diagonal, it makes kind of a butterfly, right? There's a mirror image. The purple is the mirror image across that diagonal line of the black. That is the relationship of an inverse function. Okay? And so the graph of a square root is a parabola lying on its side. Okay? That's the important thing to remember. We still have the numbers 0, 1, and 4, and then 9. But the 0, 1, 4, and 9 are not on the y-axis. They are on the x-axis. They're horizontal. Horizontal. Okay. So with that in mind, let's look at y equals square root x and see what we can do to change it. Okay. If I regraph this thing, y equals square root x, but I put a plus 1 on the outside, we take the whole thing and we shift it up. That's called a translation up. We slide the whole thing up. Everything is 1 higher. But if I put the, and also we can subtract 1. So I subtract 1, it goes 1 lower. I add 2, it goes 2 higher. Not equals 2, plus 2, plus 2. There we go, 2 higher. Minus 2 goes 2 lower. Okay? If I put plus a and add a slider for a, I can grab the slider and move it up as a gets bigger, down as a gets smaller. So I can slide this thing back and forth. up and down, up and down. Okay? Well, what if I add something inside under the radical, right? So minus or plus 1. Now it moves to the left. And remember with translations, x, when I do something to the x, it's oppositesville. You'd think that plus 1 would move it to the right. It actually moves it to the left. Because what it does is it makes the function think that x is 1 bigger than it really is. Okay, so it moves it to the left. If I subtract 1, it'll move it to the right. If I go plus a, as a gets bigger, it moves to the left. As a gets smaller, it moves to the right. Okay, those are the primary transformations you're going to be playing with. But there are others. So for example, I can multiply y equals 2 square root x. Okay, so everything is twice as tall. It still starts at 0, 0, but instead of going through 1, it goes through 2. Okay, I can flip it by putting a negative. Now we get the bottom half. It flips it over negative. Okay, if I multiply x by 2, I don't think this is in the lesson, but it compresses it horizontally. It's now half as wide. Because remember what multiplying x by 2, it makes the function think that x is twice as big as it really is. So it compresses horizontally. Okay, but the big ones to remember, if I add inside, it moves it left. If I add outside, it moves it up. And I think you should probably know if I multiply by 2, it makes it 2 times taller. Okay? All right, and if you multiply by a negative, it flips it horizontally. All right. By the way, if I make the x negative, it flips horizontally instead of vertically. It flips over the y-axis. Okay, so all of these, and we can combine them in various ways. So for example, if I do this, y equals square root x plus 2, it's shifted 2 to the right, 2 to the left, I mean. Minus 1, now it's shifted down 1. 2 to the left and down 1. If I put a 3 on here, it's now 3 times taller. Everything is stretched vertically 3 times. Okay, so those are modifications on the function y equals square root x.